The universe doesn't give up its secrets easily. It hides them in the crushing blackness between stars, in the silent dance of distant galaxies, and in the fundamental forces that hold everything together. For all of human history, we have stared up at that vast, dark ocean and wondered, what's out there? Are we alone? We are a curious species driven by an insatiable need to know, to explore, to push the boundaries of our understanding. This cosmic curiosity is what built telescopes, what launched rockets, and what sent tiny, robotic ambassadors into the great unknown on our behalf. One such messenger, a true pioneer, is Voyager 2. Launched decades ago, it has traveled farther and seen more than any human ever has. Let's rewind the clock. The year is 1977. The world was a different place. But in the halls of NASA, scientists and engineers were focused on a rare cosmic opportunity. A planetary alignment that happens only once every 176 years was upon them. This special arrangement of the outer planets, Jupiter, Saturn, Uranus, and Neptune, would allow a spacecraft to use the gravity of each planet to slingshot itself to the next. It was a grand tour, a cosmic game of leapfrog across the solar system. Voyager 2 actually launched before Voyager 1, blasting off from Cape Canaveral, Florida, on August 20, 1977. For years, it soared through space, a lonely traveler on a precise and carefully calculated path. It revealed the swirling, violent storms of Jupiter's Great Red Spot, the intricate and stunning beauty of Saturn's rings, and then it went where no probe had gone before. It flew by the ice giants, Uranus and Neptune, revealing them to be worlds of bizarre and unexpected wonder. For decades, Voyager 2 sailed onward, leaving the familiar neighborhood of planets far in its wake. It was traveling through a vast, invisible bubble created by our sun. This bubble is called the Heliosphere. Think of it as the sun's magnetic kingdom. It's a region of space filled with a constant stream of charged particles flowing outward from the sun, known as the solar wind. The heliosphere acts as a cosmic shield, protecting our solar system from the harsh radiation of the wider galaxy. Voyager 2's instruments were designed to measure this environment. It has sensors to detect charged particles, magnetic fields, and plasma waves. As it journeyed farther from the sun, scientists watched its data closely, waiting for the moment it would punch through the edge of this bubble. The edge isn't a simple line, it's a complex, turbulent boundary region. On November 5, 2018, it happened. At a distance of more than 11 billion miles from Earth, Voyager 2's instruments registered a sudden, dramatic change. The flood of solar particles it had been measuring for 41 years abruptly dropped to almost nothing. At the same time, the probe was hit by a powerful wave of galactic cosmic rays, high-energy particles originating from supernova explosions and other violent events far out in the galaxy. This was it. The data was clear. Voyager 2 had exited the heliosphere. It had crossed the heliopause and was now officially flying through interstellar space. What Voyager 2 found at the edge of our solar system was not what scientists expected. The theories and models had predicted that the heliopause would be a relatively smooth, straightforward boundary. It was supposed to be like crossing a shoreline moving from the water onto the sand. But the reality Voyager 2 reported was far stranger and more complex. The boundary wasn't a clean line. Instead, it was a thick, messy, and surprisingly dense frontier. The first major surprise was the sheer density of the plasma just outside the heliopause. The interstellar plasma that Voyager 2 encountered was significantly denser and colder than predicted. It was as if the spacecraft, after traveling through the thin, hot solar wind, had suddenly plunged into a thicker, cooler cosmic fog. It suggested that the interstellar medium was being compressed and piled up against the outside of our heliosphere, like snow piling up against a snowplow. Another baffling discovery was related to the magnetic fields, but Voyager 2 found that the galactic magnetic field just outside the heliopause was mysteriously aligned with the sun's field on the inside. It was as if the galaxy's magnetic field was draping itself smoothly over our solar bubble, conforming to its shape. Perhaps the most dramatic finding was the evidence of a boundary layer or a kind of cosmic waiting room. This buffer zone was much thicker and more defined than anyone had imagined. The edge of our home was not a quiet shore but a churning, seething frontier. The data sent back by Voyager 2 didn't just answer questions, it created a whole new set of them. The findings were so unusual that they sent scientists scrambling back to their drawing boards. The universe, it seemed, was more creative than we were. The mystery of the increased plasma density is a prime example. Why is it so thick out there? One idea is that the interstellar magnetic field is draping over the heliosphere and slowing down the plasma, causing it to pile up. Another possibility is that the heliosphere itself creates a sort of wave in the interstellar medium, like a boat moving through water, and this wave causes the material to compress. This suggests a powerful and unexpected connection between our solar system and its galactic environment. It's a profound thought. Our little home in the cosmos is not just in the galaxy, it is physically connected to it in ways we are only just beginning to see. The boundary isn't a wall, it's a handshake. We sent Voyager 2 to the edge of the solar system to find answers, and it sent back a cosmic puzzle box. The probe's observations have fundamentally changed our understanding. The universe is not obligated to make sense to us on our first try. For the scientists on the Voyager mission team, the signals from Voyager 2 were the culmination of a lifetime of work. Many of them have been with the project since its inception in the 1970s. When the data confirming the heliopause crossing arrived, it was a moment of profound triumph and deep wonder. Ed Stone, the longtime project scientist for Voyager, described it as stepping into a new place, a region no one had ever sampled before. The initial reaction to the unexpected measurements was one of cautious excitement. Science is a careful business. But the signals were clear and consistent. The strangeness was not an error. It was a feature of the universe itself. The Voyager team and astrophysicists around the world are now engaged in this very process. They are creating complex computer simulations, trying to replicate the conditions Voyager 2 measured. Some scientists focus on the magnetic field interactions, while others explore the dynamics of plasma physics on a massive scale. The mystery has sparked a new wave of research. The scientists aren't frustrated by the mystery, they are energized by it. It's a reminder that there are still fundamental things about our place in the galaxy that we simply do not know. The journey of Voyager 2 forces us to confront the sheer scale of the cosmos and the limits of our knowledge. For all that we have discovered, we are still just beginners. The universe is a book with an infinite number of pages, and we have only just read the first sentence. Voyager 2 has traveled for nearly half a century at speeds of over 34,000 miles per hour, and yet it has barely left our cosmic front porch. The nearest star to our sun, Proxima Centauri, is still more than 40,000 years away for the spacecraft. Sometime around the year 2025, its plutonium power source will decay to the point where it can no longer operate its scientific instruments. Its faint signal to Earth will cease, and it will go silent forever. But its journey will not end. It will continue to drift through the Milky Way for millions of years, a silent ghost ship from Earth. It carries with it the golden record, a testament to who we were and what we dreamed of. It is a piece of us set loose in the cosmos, a hopeful message waiting for a recipient that may never come. The spacecraft will long outlive its creators and our civilization. It is a monument to our curiosity. The universe is not just stranger than we imagine, it is stranger than we can imagine. There are plans for new interstellar probes, missions that will be designed with the knowledge we've gained from Voyager, ready to tackle these new questions head-on with more advanced technology. It's a story of a species that looks up at the night sky and is not content with just wondering. We are a species that builds, that explores, and that dares to reach for the stars. The greatest mysteries are not yet solved, the greatest chapters in our cosmic story are not yet written, and the grandest adventures are still waiting for us in the endless, starlit dark.